Financial algebra. We are going to cover lesson 9.4, which is on fixed or variable expenses. And this is for companies, restaurants, any business really. So I'm going to go over the two different kinds. A variable expense means that it varies with the amount of or the quantity in which you produce. So the more items you produce, the more expenses. The fewer items, the fewer variable expenses you have. So this variable changes based on the quantity you're producing. Fixed expenses, kind of like a PG&E bill or the cost of your employees, those don't change whether you make 0 product or 100 products. So this is a fixed amount. This amount doesn't change, kind of like my Netflix bill. No matter how little or how much TV I watch, my bill is the same. And the opposite is PG&E, right? The more lights and AC and fans I use, the greater that bill is. And so that is a variable expense. It changes based on my usage. Total expenses, so they use this formula for total expenses. Total expenses equals your variable plus your fixed. And then revenue, that is the price at which you're selling the product for times the quantity. Now, this is before your expenses. This isn't the money. This isn't your actual profit. This is just revenue. This is income from selling your product. To know what you actually made, you would then have to subtract your expenses. So we're going to do some examples together. Number 1, the fixed expenses. So this is, I'm going to grab my pen. Here is our fixed expenses. This amount is not changing. The labor and materials for each widget, remember widget is like a generic product, costs $16.44. Represent the total expenses as a function. So expenses equals, it's $16.44 per widget. And it says the quantity Q. So I'm going to use Q. And make sure your Q doesn't look like a 9 plus your fixed. And so that's how I'm going to structure everything. It's your fixed times Q plus your variable. That's how we're going to set up our functions. And so this equation here is your answer. Number 2, a widget manufacturer's expense equation is E equals 14Q plus 29,000. Now, based on what we did, this is our, I'm sorry, I switched these. Woohoo, I wrote that backwards. This is our variable expense times Q plus our fixed. Whew. So what are the variable costs to produce one widget? So I know this $14 is our variable. This right here is our fixed. Variable, this is also our slope, which we will cover later. So it costs $14 per widget based on how that equation is set up. Sorry, there is something wrong with the lens and it's a little blurry, so I was trying to fix that. All right, so next one. And number 3, the Catania Cat Corporation manufactures litter boxes for cats. Here's their expense function. Find the average cost of producing 10,000 litter boxes. So in order to do that, I first have to figure out how much it costs to produce 10,000. So my expenses equals $4.18 times the 10,000 boxes plus $82,000. Now, to find the average, I'm then going to divide that by the 10,000, but we can do it in steps. So this equals my total expenses are $123,800. Now, to know the average cost per box, I would then divide this by 10,000. And if you enter that in your calculator, I get that each litter box costs about $12.38. Average cost per box. Okay. So number 4 is kind of a play off that. Here is our expense function, express the average cost algebraically. Well, my average cost would be the expense equation, so 295 times Q plus 712,000 divided by the amount we produced. And that's it. They just wanted the equation. Number 5. So the Mizzy Corporation has created a demand function for one of its wrenches. It expresses the quantity in terms of P, blah, blah, blah. The demand function is Q equals negative 98P plus 5788. Their expense function is the following. So they're wanting us to substitute this in for Q and express the expense function in terms of P. So since they're telling me what Q is, I can substitute this yellow right in here using parentheses. So E equals 23, and then in parentheses, we're going to write what we highlighted. And then plus 68,000. So I'm substituting right here, negative 98P plus 5788. So using my calculator, I'm going to have to distribute 23 to each of these. So E equals 23 times negative 98P is negative 2,254P. 23 times 5,788 is 127,336. And then I'm going to bring down this 68,000. And now I'm going to combine like terms. So negative 2254P remains the same, but I'm going to combine these because they are like terms. So if I combine these, I get 195,336. Next one, a corporation's expense function is the following. The demand function, so this is how much is in demand, express the expense function in terms of price. So again, I don't know what E is, but they're telling me that this represents Q, so I get to substitute it into here. So we're going to do the same process. E equals 7.50, but in parentheses, I'm going to write what we highlighted in yellow, and then plus 34,000. So I'm substituting it in here. And then we are going to have to distribute this, so we're going to multiply. So I get E equals negative 41.25P plus 45,000. And then I'm going to just bring down that outside 34,000. Then I'm going to combine these. And so my expense function in terms of the price is negative $41.25 times P. Plus, if I add these together, I got 79,000. All right, the next thing that this book covers is our break-even point. And break-even means your sales equals your expenses. You've gotten to zero. You didn't make anything, but you didn't lose anything. So break-even is when your expenses equals your revenue. You obviously don't want to break even, right? I mean, you at least want to break even, but hopefully you want a profit. So in order to have a profit, you need to sell. You need to have more revenue. And I'm going to write that down. Profit is when revenue exceeds expenses. A loss is the reverse. When it costs more than you actually made. So number 7, Wechsler's manufacturers, they create a monthly equation of all expenses in 1 month of manufacturing. So here's their equation right here for expenses. They plan to sell at a wholesale price of $3.50. So part A, how many widgets must be sold so that the income is equal to the expense? So in order to do this, I'm first going to set up that my revenue would be $3.50 times my quantity. So to find, this is asking, part A is asking for our break-even point. And in order to find it, I'm going to set my equations equal to each other. So I'm going to set 3.5Q equal to that one. So I'm going to set them equal to each other. 3.50Q, when is it equal to 210Q plus 7,600? So I'm going to subtract 210Q, right, and I'm going to bring it over here. And that gives me 140Q equals 7,600. And then we're going to divide by 1.4. And I get Q equals, hold on. And it says round to the nearest widget, right? I can't have part of a product. So 5,428 point, I think I got 0.57. So Q equals 54.29. So I would have to sell 5,429 widgets in order to break even. So anything above that would be profit. If the company only sells 29, right, I need to sell 5,400 to break even. If I only sell 2,900, how much money will they lose? Well, first let's figure out the revenue. They're selling each one for $3.59. So $3.50 times 2,900 gives me a revenue of $10,000, $10,150. Then we're going to calculate our expenses. So my expense equation is 210 per widget, so times 2,900 plus 7,600. That gives me a total of expenses of $13,690. So notice that I made less than it cost. So my revenue minus my expenses gives me a negative $3,540. So I had a loss of $3,540. Number 8, find the break-even point for the equation 6.25 times the quantity plus 259,325, and here is my revenue function. Now remember, to solve these algebraically, I'm going to set them equal to each other. So I'm going to set one orange equal to the other. And so I'm setting them equal. So on the left, 12Q equals 6.25Q plus 259,325. Okay, then I'm going to subtract the 625Q and I get, what is that, 575Q equals 259,325. Then I'm going to divide both sides by 575. And I get Q equals 45,100. So they would have to sell 45,100 products in order to break even. It's a lot. Their expenses must be quite a lot. All right, number 9 has lots of parts, but you do have one like this on your homework, and so that's why I'm going over it. So they have given us their variable expense and their fixed. So how much does it cost to produce one lens? Okay, so let's talk about one lens. It would be, so one would cost them $12.66 per unit times 1 plus 111,200. And that would give us $111,212.66. So that's the cost of producing one. The cost of producing 15,000 would be $12.66 times 15,000 plus your fixed expenses. Remember, those fixed expenses don't change whether you make 1 or 100. It doesn't matter. Like maybe that's the cost of the lights on and having the building open and the machines. So if you enter this one, 1266 times 15,000 plus, 1, 2, 3. This cost me $301,100. Express this function algebraically. What is the slope? So my expenses equal 1266 per unit, per quantity, so Q, plus my fixed expense of 111,200. Okay, so here's my equation. My slope is the number in front of Q. Okay, we're going to skip C. D, what is the average cost to the nearest cent of producing 15,000 lens? Now remember, we take the cost, which we did above, 301,100, and I divide it by the 15,000 lenses. And so if you divide that out, I got that the average cost would be $20.07. What is the average cost of producing 17,000 lenses? So let's do the cost. It's $12.60, so this is part E. $12.66 times 17,000 lenses plus your fixed cost, so 200, divided by 17,000 products. If you enter that in your calculator, we now have a smaller average. The more you produce, the smaller your average cost is. So now it only costs $19.20 per unit. And then finally, part F. So if you look at when I produced 15,000, my cost was $20. When I produced 17,000, my cost was $19. So I could say that the average expense, it's asking if it increased or decreased, decreased. So the more product you make, the less it costs you to make it. We only have 3 more. Number 10. The expense equation is here. If the owners have $100,000 to start up the operation, what quantity can they produce initially if they spend all this money on production? So again, we're setting these equal. So if I only have $100,000 to spend, how many products can I make? So 455Q plus 28,500. Okay, I'm going to subtract the 28,500. And that should give me 71,500 equals 455Q. And then I'll divide by 455. And so they will be able to make 15,714.28 products. You can't make 0.28 of something, so we're going to round that to the nearest product. So 15,714 widgets. Okay. The last 2. So number 11, what are the coordinates of the break-even point? Our break-even point is right there. We always list our x-axis letter first, so M, comma, our y value. If U units are produced, so here's U. Notice this is my revenue. This is my expenses. So if I only produce U units, that would be a loss. Expenses exceed revenue. Your expenses are greater than your revenue, so you're going to have a loss. Compare the profit made at if W units compared to T. Well, W, there is a greater difference between W and T. There is a greater between revenue and expenses at W. Therefore, W would have a greater profit. And that completes this lesson.